With my Asteroids Deluxe here. I got the monitor pulled out, the control panel, everything's kind of looking pretty sad, right? But where we left this, and I had the monitor plugged up there, but where we left this was the deflection board had some minor shaking to it. So we resolved the kind of weird vector issue by replacing the 6502, but there was still some small shaking. I'm filming here because that's where the monitor was, but there was still some shaking on the just the image itself. And I thought that maybe it would be the B+ pots or something. I don't know, something on the deflection board, but wasn't obviously because it was working. So let me pause for a quick second and go to the bench. So what I actually did was, this is a spare deflection board I had, and also a high voltage cage, because I actually have I don't know, do I have it over there? Where's that monitor at? Anyway, so I have a monitor with that this came out of a tube that has a dynamic G1 short, and so I had pulled the parts out of that to put into the Asteroids Deluxe one, and so I'm trying to explain the sequence here, but basically this deflection board was not 100% working, so I could put it in to the system. The spot killer was on, and so and then I had to basically crank up the brightness, and I did some troubleshooting and basically figured out that it was part of the spot killer circuit. I replaced these. What I did is I swapped these from the good working one that was in here that had the shaking. I took the transistors Q05-501, 500, there we go, 500, 501, and 502 out of this deflection board and put them in here, and the shaking went away, and the spot killer behavior transferred to this deflection board, which is the original one I had in the Asteroids Deluxe. So you can see that I had recapped it back in 2014, so it's been recapped, but it still had the image shaking, and now because I swapped the transistors, it actually has a spot killer problem right now. The other thing I did is I ordered a cap kit from Ian Kellogg, and I recapped the high voltage supply, so that's been done as well, and I was adjusting the high voltage, etc. So there's a few things I want to show on this video, but this is kind of just setting the stage. I've recapped the high voltage supply. We're going to use a high voltage probe to further measure and set the high voltage. It's got to be something like 20,000 volts or something crazy up here, and I'll get the exact number later. And also fix the spot killer problem. So what I figured we'd do is hook this monitor up, show you the spot killer behavior that is on this deflection board, and we'll call this deflection board A, that has now it has a spot killer problem, as well as once we fix that, it'll have the image will shake, and then we also have this board that I can put in there and show you that the image doesn't shake and there's no spot killer problem. So the plan of attack is to kind of show you the behavior, and then I also got new B+ filter caps that we will put into this board to see if that solves some of our shaking of the image and stuff. So I guess that's basically all I can say. Is that's kind of the plan of attack right now, is kind of show you the behavior, the current behavior of the monitors, and just wanted to recap kind of what we were initially trying to fix was the shaking of the image. That's why I tried to get this deflection board to work, But to get this deflection board to work, I had to take the transistors off of this one in the spot killer circuit. So anyway, that's where we're at. And let me move this, I'll move this monitor back over there. We'll power it up real quick so you can see the behavior. So what we're going to do is I'm going to turn on the game, and we're going to watch the spot killer light that's right there. And you see it come on and basically stay on, right? And it's not going off. So it should come on for a split second, but then go off as it gets a vector, as it gets like a signal, XY signal, I guess. But it's not. So let me pause real quick, set this up on the tripod so you can see the screen. Before I do that, I just figured I'd show you that the game is definitely running. You know, we could probably play it blind and you could hear it and stuff. I have the speaker disconnected, but usually when those LEDs flash like that, it means it's okay. So what we're going to do is set this up on the tripod. And you'll see that when I see if I can turn this so I can see what I'm doing. When you see when I do this and I turn up, basically what I'm doing is turning up the brightness. There we go. If I turn up the brightness, you'll get that spot there and a little spider effect, right? But if I turn it down so I don't get the dot in the center, it goes away, like the whole image goes away. So you can see that there's definitely deflection there. You don't want to leave it like that. That is bad, by the way, leaving it like that with those spider lines going everywhere. So that's kind of when you know there could be a spot killer problem. And one way you can quickly disable the spot killer is to, and you shouldn't leave it like this, but if you think you're having a spot killer problem, what you can do is that LED right there is desolder that. And that's what I did. And I then had brightness control. My brightness and contrast worked correctly. So that's kind of how I knew that, or had a hunch that the problem was in the spot killer circuit. At that point, I took the transistors, I tested them. They all tested okay with a diode test, and then I swapped them in the other deflection board, known good ones, and it worked. So then I ordered some replacements. So that's where we're at now. So that's what the deflection board. So let's go ahead and fix this. Okay, so there's two ways that people discharge monitors. One is with something like this, a screwdriver, long screwdriver attached to the chassis, and then stick it under the anode cup like this, if you can see that, or like that, to discharge the monitor, right? Now, in the Vector monitor guide, it says don't do that, that you can potentially destroy the anode cup. The other thing is, because I have this chassis, this whole monitor on a bench, it's not actually tied to earth ground, so I could discharge it to this chassis, and then it could, or this metal frame, I mean, and it could actually jump somewhere else. I've never had an issue with that, but usually you want continuity to earth ground, I think. So the other way that you could do this is with a high voltage probe that looks like this. You guys can see that. This one here does not have a built-in meter. It is a Beckman Industrial model HV231-10. It comes with a couple leads that you can plug into your multimeter right here, and then a ground thing. So one of the things I had to do though is you see this big round tip. Can you guys see that okay? See that big round tip? Hopefully my angle here is a little messed up, but that's kind of hard to get under that anode cup, right? So what I did is I went online because I did want to measure the high voltage probe. I've had this for a while, but I actually haven't used this thing yet in practice. But I got this little clip like this. I had to buy them in a pack of 10, so I'll probably be offering them up to somebody that wants them because I don't need 10 of them. And then you kind of slide it on top like this, and I guess I'm going to put my little cone back on top of it like this. So we're doing this for the first time, guys, right with you, because I haven't actually experimented with this yet. I did stick it with trying to get it with the cone under there, and it just sucked. It didn't work very well. So let me get my multimeter. And we will set it up to, let's say, DC volts. Turn the light on. Can you see that okay? Let me zoom in. Like that, okay, and we're going to set up put our leads in. Put our ground on, even though it's not tied to earth ground. And then we're going to slide this, maybe I zoom out a little bit. Slide this under the anode cup. Right like this. If I can get it under there. There we go. So we're just kind of draining the voltage off, and I could just leave it under there like that. So this is like the safe way, if you can see that. I think you can. Yeah. The safe way to discharge a tube before you start working on it. So honestly, I barely ever do it unless I know that I'm going to be touching the anode or working in the high voltage section. If I'm working over here, I don't really worry about it. I remove this deflection board all the time without discharging the tube. So maybe I'm an idiot though, but while that's discharging a little bit, I am drinking this Golden IPA Beer Camp. Can you guys see that? Yeah. Golden IPA Spring Seasonal. It's good. I like all these beers. Alright, so anyway, I think that's enough. So this thing was the thing that I was missing. I mean, this makes it a lot easier to get in there and measure and also set your high voltage. There's a couple ways you can do it, and I'll cover that here as well, but I just wanted to show you like the discharge there. 0.02. I mean, I guess this is basically almost nothing at this point, voltage wise. So we'll leave it alone. Okay. So with that, we will go ahead and remove the deflection board. You got it. Yeah, it's kind of hard to see. Let me move this, pause, and come back on the other side. So you got to remove this connector here. These are the connectors to the the frame-mounted transistors. Then this one in the middle is to your yoke. This is to the other frame-mounted, either X or Y or both, or one pair is for, you know, X and Y on one side, and one pair is for X and Y on the other side. And then that's it, really, and it's pretty easy to take this deflection board out. I don't even have it set in all the way. It's that simple. Just like that. Yeah, whatever. Right there. So we have the deflection board out. So now we can go ahead and replace Q500, 502. I might do them one at a time. I don't know. I'm going to test them maybe again just to double check. So I'll be right back. Okay, actually I remember now. You can see how one of those transistors is actually kind of higher up. That is Q502, and it is a, see if I can, there we go. See if I can I get that to focus? Dang, heck no. Can't get that to focus. Sorry about that. But anyway, it is a 2N3906. I had one on hand, and I swapped that out, so I know that's not the problem. So I know the problem is got to be either Q501 or Q500. And Ian Kellogg, I ordered some from him. I'm just going to go ahead and replace both of those. So I replaced Q502. That wasn't the problem. So 500 or 501's got to be the problem. And we'll do a diode test on them just to verify that they test bad, or if I can tell that they test bad. Okay, be right back. It's not going to take long. So we're replacing, let's see if I can get that out of the way. We're replacing, there's big shadow there, huh? Q500 and Q501. It's only going to take me 2 seconds to desolder these, by the way, so I'm just going to take my desoldering gun like this. There's one Q500 right here. Man, I need to clean that, I think. There we go. Alright. So that's pretty easy. You know, you just desolder them. There's a line. If you can see that, there's a line. There's a line. Says Q501, and then there's a flat line. There we go. That's better. Right there. Yeah, it's backwards because, or something upside down, but whatever. You see that flat line there? That's telling you that the flat part of the transistor needs to face that flat line. So you kind of just bend it out. And these transistors are MPSA06s. So it's going to go like this. quick little solder. Alright, that's Q501. Now we just have to do Q500. Same thing, make sure the flat part of the transistor is facing that line. And it's relatively straightforward there. I'll be right back. I do this one on my own. Got everything hooked back up. I just figured I'd spare you guys that. But we are ready to go and power this thing up and see if our spot killer problem's over. I did save the transistors so we can come back and test them because we're going to be back at the bench anyway to replace these B plus caps. Hopefully these fit. I was looking at the snap-in style like that. I don't know. Hopefully I can get those to work in this board. But anyway, we'll test these transistors. If this fixes our spot killer problem, I'll be pretty happy. So, be right back. Okay, here we go. I'm gonna turn on the game. And boom, spot killer lights off. So it was definitely either Q500 or Q501. I know you guys can't see that. We're waiting for the image to come on now. I might have to adjust the brightness. But the spot killer is out over. There we go. And now you can see we can get some image. And the way you're supposed to adjust this is basically turn the brightness up until you just start to see an image, and then adjust the contrast for proper luminescence or whatever, illuminance. There you go. So that looks pretty good. Now, unfortunately, it's let's play a little bit. Can you guys see that? Okay, yeah, I think so. We'll see if we still get the shaking. Because remember, this one also had the shaking. I wonder if would those transistors cause other problems? Because I don't see the shaking right now, guys. And this is the deflection board that did have the shaking. No, hold on, no, this one, that doesn't make sense. I should definitely see some shaking here, because these, the original transistors on this board are actually in a different board. So these are just two separate issues, spot killer issue and some shaking. So this deflection board definitely had shaking, but I don't see it right now. Let me put it in test mode. Maybe because the image is kind of small. We'll adjust that a little bit. Let's see. Bear with me as I flip this around here. Kind of a little bit of a weird angle. I'm going to adjust the XY pots on the game board. This is actually I can still go bigger or wider at least. That's as wide as it gets, huh? That looks like dog dookie. I wonder why that's as wide as I can get it. So maybe we have something else going on now? Because I should be able to get that image as wide as it can go. It's almost like partial collapse or something. Yeah, there's definitely something weird going on the edges of the screen. So I don't see the image shaking. We got the spot killer off, even though that originally wasn't part of the problem on this board. I just moved those transistors over. I'm puzzled a little bit, and now we have some weird thing where we can't get the width to be 100%. See, this is what happens as you start messing with stuff, and you start messing with the stuff, you run into some other problem. I mean, it doesn't look too bad, but maybe I don't have enough high voltage. Is that why it's not going as wide? Look at the linearity. Oh, you know what? Maybe on the deflection board, some of the linearities controls got jacked up. I don't know. Alright, so back to the drawing board, because I was hoping that we would just replace the B plus pots and then fix the shaking, and then everything goes away. But now it seems like I have some type of adjustment problem, so. Alright, I'll be right back. Okay, just for being complete, I guess, or for completeness sake, we're going to test these original transistors here. These were TPS 98s, which are the ordered replacement from that I got from Ian Kellogg is MPS A06. I think that's it's kind of a small upgrade, I think, to the original TPS 98. And it is a TO92 transistor. Actually, you can find this on Clog too. I made this this sheet just by grabbing a whole bunch of different stuff online, but it tells you like what kind of transistors, the shape of them, and this is a TO92, so it tells you that, when you're looking at the flat side, the one on the left is the emitter, the one in the middle is base, and the one on the right is collector. And then on the other side I have kind of how you should read it. So we're going to take it, so if we look at it this way, yeah, you guys can probably barely see that, but anyway, I like to use these mini clips on here, and I set my meter test to diode. So we're going to first go from base to base to emitter, and we should get, and this is a NPN, so we should get a reading 0.593. So that reads good. Okay, then base to collector, okay, we should get low as well, if you guys can see that, 0.61. So that works as well. So that looks good. So then we go emitter to base. We get over limit or out of limit or whatever, and then emitter to collector. That reads correctly. Then we switch our red to our collector, collector to base. That reads okay. Collector to emitter. That reads okay. So this one, obviously with the diode test, checks out okay. So let's check this one. That doesn't mean, I guess, that it is okay, but it passes the diode test, which is the only way I know to test these darn things. So here we're going to go again with base. So we're going to go to the middle first. Base to emitter, 0.63. Base to collector, 0.64. Okay, so that's correct. Emitter with the red lead to base, over limit, to collector, over limit. Then we go red to collector, over limit, over limit. So like I said, both of these actually test fine with a diode test. So, and they were still the problem. So maybe somebody else can tell me a better way to test transistors to see if they're bad. I know for a fact they were bad because we replaced them, and my spot killer problem went away. So, not sure what the deal is there. But anyway, so these are going in the trash, and probably, did I have another one? Yeah, this other 2N3906 that I replaced. Okay, so what else can we do? We have a known deflection board. I think it's kind of working now, and I don't see the jitter or the jumpiness, so that's kind of problematic. What I think I'll do is put in this other deflection board where I swapped out the transistors. These still have the TPS 98s in them. Maybe I'll put in this board and see what it looks like. The other thing is, you know, this connector here, what is that connector? P500, actually looks good. It's pretty decent looking on this one. It doesn't look so hot on this one, so I was going to actually replace it on this one as well. So anyway, we know that the one that I don't have the sticker on it was the one that had the shaky video, and now it's like it doesn't look like it's going full screen and stuff. So let's swap that out, and if that changes it, then we'll go ahead and see if you guys can see that. There's the monitor. Then we'll check the high voltage and adjust the high voltage, so make sure that it's correct. I already did it, and I was doing it reading these pins. Actually, here I think like reading the 90 volts coming off of that, but I don't think that's a great way to do it. You're supposed to have the high voltage probe. So, all right, I'll be right back. Okay, so I just removed the deflection board that was in there, and let me see if you guys can see that. So, if you can see that, there's definitely discoloration on here and stuff, and this is where a lot of voltage comes in. So I'm just going to go ahead. I have the part, so I'm just going to go ahead. I got a 10-pin molex for me to repin the connector, which is over here, if you guys can see that, and I have new header pins. So I'm just going to go ahead and do that real quick. I'm going to count 10. 1, 4, 5, 6, 7, 8, 9, 10. So just double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And that just was going to go right there. Looks like pin 5, 1, 2. Yeah, pin 5. 1, 2, 3, 4, 5 needs to come out. 1, 2, 3, 4, 5. So usually I just, if I can, just pull that out like that. Hopefully that was on camera. So now I got my pin 5 out. So that's the way that goes. Put this back in my container. And then we have our molex connector that's going to go like this. So I'll spare you guys, but basically just need to desolder these pins. I should probably put on my bigger bit. I mean my bigger attachment, bigger hole attachment. But it goes pretty fast. If you don't have a Heiko desoldering gun, I highly recommend it. Very frustrating doing this with the, yeah. I mean, look at that. Bam. I mean, thing comes right out. Takes 2 seconds. We put in our pins. And then just solder them up. I mean, you're talking about something that took maybe real time, what, like, I don't know. It probably didn't even take 30 seconds. There we go. Probably should have a fan blowing here. Alright. I'm kind of doing that from a distance because of the camera, so I'm going to check my work. Looks good. And we got our new header pins there. I don't know if that's going to make a difference or not, but you know what? Since we're doing all this work on this deflection board, might as well fix that. So now what we need to do is we need to, one by one, basically take these pins out and cut them, recrimp them, and I'll spare you guys that. That's kind of painful. Okay, so actually I didn't have Trifurcon pins that with a big enough gauge connector. This looks like 18 to 20 or something like that. I mean the gauge is pretty decent size, but I do have these like box. I don't know if you can see that. They're kind of like these box pins. So these work as well. I don't know if they're, I can't keep track of like what everybody likes and doesn't like, but anyway. So what we're going to do is we're just going to do one at a time, cut these off like that, and we will cut a little bit of it off. Okay, let's see here. It's probably 18. Yeah, That looks like 18. You don't need a lot of it off. This is the crimper that I like to use. This one. I have one that does both crimps at the same time, but I don't know, I kind of like this one. Right, we can go D. Kind of just stick it in there. And then you flip it over and it has the crimp for the I don't know if you guys can see that or not. I'm just working, so has the crimp for the it goes on the wire insulation. Oh, that looks like crap. Sometimes it's like too long on the wire. Alright, so we're going to put that in just like this. And it's in there. And that's it. I mean, you just do that, you know, cut, strip. And this one's a little bit thicker gauge. Probably like 16 or something. Or it has thicker insulation anyway. Get your crimper ready. Test it. Crimp the insulation. Insert, just like that. So hopefully that was on camera, and I'll be right back. Okay, so I got the connector repinned out, so that's good. We could probably go ahead and put this deflection board back in just to make sure everything works still, so we don't like start skipping steps. Probably will do that, and then we'll test it out one more time. Well, the symptom we're seeing now could be related to maybe these pots here, like R602 and some of these up here. I think those are like linearity pots or something like that. I don't know, but we should just test this anyway, just to make sure that the work we did was still good. So I'll be right back. Okay, I took out the deflection board that we were just working on, that we put the new pins on. I had tested it real quick off camera, and it still had like partial horizontal collapse or something like that going on. So, and I'm also not super happy with these crimps or the pins. They like oops, I don't have it tied all the way in, but they slide out when you're inserting them sometimes. So like I have to sit here and mess with them. So I'm probably gonna have to redo that connector with some better pins. I'll just use my Trifurcon pins or something like that. And let's see. But anyway, this is a different deflection board. Let's go ahead and put it in and see if what's possibly the problem is, as we were messing with this, one of these chassis or the frame transistors, I mean, it's starting to go bad or something like that. It could be coincidence, these transistors right here. But by putting in the other deflection board, we'll be able to verify whether it's a deflection board issue or the transistors, I guess. So okay, as you can see there, I mean, I adjusted it a little bit. I mean, it's a lot better. Let's go ahead and take it out of test mode. Yeah, so it's, I mean, this deflection board is just working better. I don't know, there's no partial collapse there, so there, now I have to start troubleshooting the transistors most likely in the XY section, so like the 600s or 700s or something like that on the other board, on the other deflection board, but I don't even know if I'm going to screw with it. Because maybe some other stuff was going on with that board, I guess. I mean, because now, see, I mean, we weren't getting the shaking, you know what I mean, after I replaced, which I don't understand. I don't know why I wasn't getting the shaking. This one looks perfect. Yeah. Be right back. I'm gonna put the tube in the yeah, so here's it's in the cab now. A little bit of a wave, actually. Can you guys see that? I don't know if you can see that. There's a little bit of a wave in the upper left corner that's noticeable. But I mean, it's definitely way better than what we had before. So I mean, it's not shaking or anything. We don't have weird vectors. I don't know. I might call it a day. We might keep looking at it. I'll have to figure it out. So, but anyway, I think that's it for tonight. I'm just going to leave it alone with this other deflection board and probably save that the one that now has partial vertical collapse for a later date. So, all right. Cheers.